Alright, so here we're talking about vertex form and intercept form. So here in gray are the two forms just without any values, any numbers in them. So vertex form is going to look like y equals a times x minus b squared plus c. So an example of that would be y equals negative 2x plus 3 squared minus 5. So if you have an equation that looks like this, then it's a vertex form. And we're going to use these two pieces of information in order to graph it. So when it's in vertex form, it's easy to identify the vertex. That's why it's called vertex form. So the vertex is simply b comma c. So b and c from the equation. So if we look at our example, we have b here, and we have c. But notice that in our general form, we have an x minus b. So b is what comes after the negative. So if you rewrite x plus 3 to have a subtraction sign, it'd be x minus negative 3. So b is really negative 3. It looks like a positive in this example, but it's actually the opposite. Then you have plus c. So if you change this to plus a negative 5, you see that c is negative 5. So the vertex is negative 3, negative 5. Then the last thing is your axis of symmetry is x equals b, because remember the axis of symmetry goes to the vertex. So x equals negative 3. So from looking at the equation, we can already identify two of the pieces without having to really do much math. So we'll do 3 examples on that. So here we have y equals negative 3 times the quantity x plus 2 squared plus 4. So remember, it's minus in the parentheses, x minus, so it'd be a negative 2, and then a positive 4. A negative, subtracting a negative, or a subtraction of a negative, creates a positive here. Okay, so we can identify b and c. So our vertex is at negative 2, comma 4. B is negative 2, and c was 4. And then our axis of symmetry is x equals negative 2. So when we go to graph this, axis of symmetry is at negative 2, and our vertex is at negative 2, comma 4. So there we already have pieces of our graph. Now the only thing we need now are some points on one side of that axis of symmetry. So we're going to do like we did in our previous assignment, make a little table, and let's find a coordinate. We can use any x value we want. I'll use negative 1. So I'm going to substitute negative 1 into our equation. Do the parentheses first. Then our exponents. Now we multiply. And lastly, we add. So y is 1. So when x is negative 1, y is positive 1. Then remember, all we do is reflect that point across the axis of symmetry to get the other point. Now I connect to make a smooth curve. And there's our graph. Our domain is all real numbers, negative infinity to infinity. In our range, we have a maximum point, the vertex is at the top. So y is going to be less than or equal to that highest point, which is 4. This way is definitely a lot simpler than standard form, in my opinion. Let's do another example. So y equals 2 times the quantity x plus 3 squared plus 1. So b is negative 3, because we have to make this x minus the negative 3, and c equals 1. So our vertex is at negative 3, 1. Our axis of symmetry is at negative 3. Graph our axis of symmetry. And then that vertex, negative 3, 1. Last thing to do, create a table of values. Let's use x equals 1. I like to pick easy numbers. You could actually, let's do this. Let's pick something even simpler. 0. So y equals 2 times 0 plus 3 squared plus 1. So 0 plus 3 is 3. 3 squared is 9. 2 times 9 is 18, plus 1 gives us 19. So when x is 0, y is 19. So count up 19. To here. Now notice, the further you are from your vertex, the higher or further away the point is that you're looking at. So if we would have chose something like x is 2, our y value would not have been as high. Now again, mirror that point to the other side, and you have your curve. Alright, so the last piece is the domain and range. The domain is negative infinity to infinity, and the range, this time we have a lowest point. So the range is going to be greater than or equal to, that lowest point is at positive 1. Let's do one last example of vertex form. So here we have x minus 3. So it's already in that form of x minus b squared. So that means b is just 3. C, it's not a plus a number. So that subtraction means plus a negative. So c is negative 1. So our vertex is at 3, negative 1. And our axis of symmetry is x equals 3. Plot our vertex. Now to create that table, we need one more point. So let's choose negative 2. So y equals negative 2 minus 3 squared minus 1. So negative 2, oh, I'm sorry, let's make that a positive 2. Positive 2 minus 3 squared minus 1. So positive 2 minus 3 gives us negative 1. Negative 1 squared is positive 1. And 1 minus 1 is 0. So 2, 0. Again, mirror that point to the other side, and you have your graph. Don't forget your domain and range. We have a lowest point, so our graph is greater, it's going up. The lowest point is negative 1. So now let's talk about intercept form. Intercept form is probably one of the easiest ways to do a graph. So in intercept form, we have something that looks like y equals some number times, and really what's happened is our equation is factored for us. So x minus a number, x minus a number. Those numbers are actually the x-intercepts of our graph. So whatever p and q are, we can plot those on the x-axis. The only thing we need now is our axis of symmetry or our vertex. Well, when you graph a quadratic and you have your x and y-intercept, the vertex is right in the middle of those two numbers. So if you find the average of them, p plus q divided by 2, that tells you where your axis of symmetry is in your vertex. Let's do 3 examples. So remember it was the form x minus p, x minus q. So here we see that p is 1, but q is really negative 3, x minus negative 3. So these are x-intercepts, 1 and negative 3. Now to find the axis of symmetry, it's just in the center of 1 and negative 3. So 1 plus negative 3 divided by 2. Negative 2 divided by 2. That's negative 1. What you can also do is see that negative 1 is right between them on your graph. Now, we know that our vertex is somewhere on here, but we need to figure out where. So remember, negative 1 is what x is equal to. X equals negative 1. So to find the y-coordinate that goes with it, we simply substitute negative 1 into our equation. So we have 4 times negative 1 minus 1 times negative 1 plus 3. So y equals 4 times negative 1 minus 1 is negative 2, and negative 1 plus 3 is positive 2. So 4 times negative 2 is negative 8, then times 2 once again gives us negative 16. So we're going to count down to negative 16. Negative 16, and here's our graph. Very skinny graph. Our domain is all real numbers. Our range, since it's going up, it's greater than or equal to that lowest point, which we just got was negative 16. Okay, second example. X minus P and X minus Q. So P is negative 1 and Q is 5. So negative 1 and 5. Find our axis of symmetry. It's right in the middle of these two numbers. So you could find them by adding negative 1 and 5 and divided by 2 to get 2, or you can look at your graph. So we know our axis of symmetry is at x equals 2. So to find the y value that goes with it, we simply substitute 2 into the equation. Now simplify each set of parentheses and multiply. So we had a positive 27. So I definitely know that 27 does not fit on my graph here. So I'm just going to plot the point right here and say that that is 27, just so we have a visual. And our graph goes down. And it makes sense that it goes down because we have a negative leading coefficient. Our domain, all real numbers, and our range. It's going down, so y is less than or equal to that highest point, which we got as 27. One last example. Notice that now we have a coefficient in that parentheses. So how does that change our x-intercepts? Well, we just set this equal to 0, or in other words, factor out that coefficient. So this becomes 2 times x plus 2, and this becomes 3 times x plus 1. So now we can see what those intercepts are. P is negative 2, and Q is negative 1. So on our graph, they're side by side. So our axis of symmetry in this case is right there in the middle at negative 1/2. Now to find your vertex, you'll substitute the negative 1/2 into the equation to find y.